to the Portland PowerShell user group. This week we're going to be, we have Brandon Olin here from Stack Overflow, and he's going to be talking about using Psake and Stucco and all kinds of other neat modules to build your module release pipeline. This one is pretty special since Brandon is the maintainer of Stucco and driving a lot of these standards and best practices that we're starting to use as a community. He's really kind of at the forefront of that, so we're really glad to have him here to talk about it. Before we get started, though, I want to thank our sponsors. We've got Sapien sponsoring the food for the evening tonight. Sapien has always been doing some really cool stuff in the PowerShell community. If you need to wrap your shells in some, your scripts in some GUIs and forms and everything, check them out. They've got a really great tool for that. And then the venue, as usual, is sponsored by Viewpoint Software. They've been great to us. So check them out as well. We appreciate their help. So without further ado, I'll introduce Brandon, let him do his own bio, and enjoy the show.
All right. Thanks, Bill. So like Bill said, my name is Brandon Olin. I am a newly minted SRE at Stack Overflow. This is probably my third week there, so I can answer some about how that operates. But like I said, it is my third week, and I barely know where the bathroom is, and I work from home. So I am also a Microsoft MVP in Cloud and Data Center Management. And you can find me on Twitter at DevBlackOps, DevBlackOps.io from the blog, DevBlackOps pretty much everywhere. So without further ado, let's talk about Psake and how to build a build and release pipeline for PowerShell. But before we start, what is a task runner? Is what Psake is. So task runners, if you don't know, basically just run tasks, snippets of automation, do one task, go to the next step, do another task. Maybe you depend on another task, etc. So task runners actually just run tasks, duh. And in the case of PowerShell, tasks are kind of synonymous with script blocks. And then it might also ask, well, tasks run script blocks. That's kind of what a function does too. And we can get into that a little bit later. But yes, basically tasks, you can kind of think of them as functions, operate a little bit differently, where you can execute tasks a little bit differently. Tasks can have dependencies on other tasks. So in this case, in this example above, I would ultimately like to run task E. Well, in order to run task E, it depends on task C and D. Task C depends on B. Task E also depends on D, etc. So those have to complete before task E can run. And in the case of a build and release pipeline in PowerShell, this could be, think of this as like, I want to build a module. Well, in order to build a module, I probably need to concatenate all the code into a PSM1. You know, I need to test a module, but before I can test it, I probably should build it. Before I build it, I probably should clean an output directory. If I want to publish, I should probably test, hopefully. Before I can test, I should build, etc. Like I said, dependencies usually run once. So in the case of this, task E ultimately depends on B, or task C also depends on B. Task B is actually only going to execute once, though. And usually in these task runners, when a task fails, the whole series of steps fail. And this is useful in a CI/CD type scenario where you're compiling code and testing it. You just want to stop the process if tests fail or some condition. You want to stop the process. So why would you want to use a task runner? Obviously, this is meant to automate some steps in your build pipeline for a module or any bit of code or any task, ultimately. Task runners kind of help you standardize what the steps are to do things. So if I need to build a module, I'm going to build it the same way every time by running this task, and that task executes that same way every time. Like I said earlier, tasks can depend on other tasks, so you can order these and kind of structure the execution the way you need to. And one of my personal reasons why I use task runners is portability between different CI tools. So a lot of people will use AppVeyor or Azure Pipelines or Travis, et cetera. A lot of these tools have special tasks that you can run to deploy a website into Azure or something like that. I personally prefer to keep that kind of logic central to my project and not in special code on the CI tool, because I want to keep this project portable. I can take a project, run it in AppVeyor, take that same project, run it in Azure Pipelines with almost zero code changes. And you can't do that if you're relying on all these special tasks that a build tool has. But that's just a personal preference. If you like to use them, by all means, use them. Like I said, same process locally too. This is one of my personal things, is I like to build a project locally before I commit it to a repository, that run my test suite and things like that, and not clutter up my Git commit history and things like that. So I can do that with a task runner and not relying on these CI tools to run these things. And ultimately, you want to don't repeat yourself. You want to do this stuff in an automated fashion with 0 manual steps. My hot take. It is, in my opinion, it is important to this build and test process to run exactly the same locally on my machine as it is in the CI tool. Does anyone have any like strong objections to that or different opinions? No? Okay. So we're going to talk about Psake, but let's mention a little bit of briefly some other task runners and related tools. You may have heard of some or all of these tools. Ultimately, these are basically just running tasks in their chosen framework. So you have things like Gradle and Grunt and Gulp. Cake, if you know what Cake is, it's kind of like, it's Make, but it's written in C#. Make, everyone should know what Make is. A lot of these things kind of base the premise on Make. Invoke Build is another PowerShell-based task framework, very similar to Psake, and operates very similarly. MS Build, well, it's not just a task runner, it does a whole bunch of other things, but it also has the concept of running tasks in a series of steps. Rake, if you're a Ruby fan, again, it's running a series of tasks to build code. So let's talk a little bit more about Psake. It is a build automation tool written in PowerShell, primarily used to orchestrate to build PowerShell projects. I personally use it for a lot of other things. It's just like a generic task runner to execute a series of steps, maybe not even related at all to PowerShell. Deploying code into Azure using Terraform or something like that. I use Psake as a task executioner to do that. Originally, it was created in 2008, so in PowerShell land, that's almost to the very beginning of PowerShell by James Kovacs. Again, it is pronounced Psake, like the Japanese rice wine, not P-S-A-K-E or Psake or something like that. It's Psake. It has had many maintainers over the years, apart from James. I am the current maintainer, so I'm the current Dread Pirate Roberts of this. Maybe not the last. But I also, if people are interested in this project and contribute, please do. I'm totally open to contributions. I know Bill has made a couple of contributions as well. So let's talk a little bit about some Psake commands. From the public side of Psake, there's really only two. It's invoke Psake. Obviously, it's going to execute the Psake tasks, and get Psake script tasks, which is going to inspect the Psake file that you pass to it and tell you the series of tasks that are available for you to run. You can kind of think of that as like a getting help on your task file. Internally to Psake, it has a couple more. Ultimately, these are PowerShell functions, but they're kind of like a DSL within Psake. They're not really useful outside of a Psake file. Task is the main one where you pass task a name and a script block, and maybe optionally a couple of more parameters of code that you actually want to run for that task. Properties is a code block where you can set up some initial variables for your Psake file. Assert is just really a helper function to test assertions and then fail if they're not true. So it's basically if a helper for doing an if-else type thing. Exec is a handy helper function to execute external commands and watch for their exit code. So if they have a non-zero exit code, you can wrap that in exec and it will fail the task if that is a non-zero exit code. You can of course do that yourself, but it's nice to have these little helper commands to do that. Task setup and task teardown are code that you can run pre and post task execution. Include is a way to include PowerShell modules, but that's kind of a legacy function I don't think is used very often anymore. And framework is where you can set, if you're using Psake, which I don't think a whole lot of people are anymore, but you can use Psake as kind of a way to wrap around MS Build and build C# projects. Framework is where you can set what your C# framework is, and it'll find the right version of MS Build to run. And format task name is a way to format when a Psake task runs, what the task, you can kind of colorize or change the format of task names to make them stand out more. So PowerShell, or Psake task for PowerShell explicitly this is a fairly built out example of what a task, a series of tasks would be to execute, to build and test a PowerShell module. And this, or at least the ones that I use. And I've kind of broke these out into two different primary and secondary tasks. Primarily, the task to build a module is obviously build, test, and then publish it. Those could have dependencies on different subtasks, if you will. In this case, if I wanted to publish, well, I probably should test that module first. So I would run a test task. A test task could maybe run an analyze task, which would run PS script analyzer, and a pester task to run your pester tests. Before any of those can execute, they probably should build the module. To build the module, you can get as fancy as you want to build it. In this case, I'm doing a couple things to build help documentation based on Markdown, and you can extract those into separate tasks. You can also stage the files, which is really just kind of quote-unquote compiling the PowerShell module, even though compile is probably not the right word because you're not really compiling, you're really just concatenating things. Clean, if you're going to build something into an output directory, you probably want to clean that output directory first, and then maybe you want to run some type of initialization code. So, pretty, I don't want to say complicated, but extensive series of tasks to build a module if you want to cover all your bases. So let's actually look and see what that looks like. So I will go to demo 1. So here I have a very simple module using kind of the more well-known structure for PowerShell project or PowerShell modules, where you have a public and private folder with your public and private PowerShell functions separate from your manifest and your PSM1. I'm not doing anything special in this module. What I want to show you is a Psake file. And this is what they actually look like. And this basically is what mimics that graph I showed you earlier. You have some properties, or you want to initialize some variables, and I want to determine what my current directory is, what is the folder that the PowerShell module is in, where is the manifest, what is my PowerShell version. I'm trying to be a good citizen and write cross-platform PowerShell, so I can't assume that a path separator is a semicolon in all cases. So these are basic initialization steps. You have this task, this task called init, which you could optionally run some initialization tasks, maybe get dependent modules or do some type of setup. You have a test task, which has a dependency on init and analyze and pester. By itself, doesn't actually do any code. It's kind of a wrapper to execute these other dependencies. So if we look at the analyze task, this is where I'm actually running PowerShell script analyzer. against a built module with this output directory here. So like I said, this analyze actually depends on a build task executing first. Not everyone does this, but it is, I think, important to build a module before you actually test it. You know, yes, you can run script analyzer and pester against a PowerShell module that is not kind of concatenated into, a big monolithic PSM1. But that's becoming a more and more popular thing where people are, for a couple of different reasons, but quote unquote compiling a module into one giant file can speed up import time. You should test after you do that, not before. This pester task, obviously, again, depends on build. And essentially, all this amounts to is I'm running pester against that output module. Create markdown help. Does anyone know the platypus, the platyps PowerShell module? Have anyone heard of that or not heard of that? That is a module. It's pretty handy. So comment-based help. Let me start there. Okay, I don't have any in this example. Shame on me. Sorry, new laptop and the keyboard sucks. So I would do comment-based help in all my PowerShell functions. platyps will inspect your module and get the help for it and actually convert it into markdown files. And you can use those markdown files to post to a website, as a readable documentation. It also can compile them, convert them into MAML, which I'll show you in a second, which is PowerShell's XML-based help documentation, which you should never, ever try to write manually. Suffice to say, platyps is a good way to take that, to extract all that comment-based help, put it in easily consumable markdown. You can optionally even just edit that markdown and put it back into your module when you build it.
So what's the reason behind using, say, the XML file versus the comment-based?
The XML help, if you're going to do localization, is a big one. So, and I'll show you that when I run this, I'll show you where that XML help gets stored. A couple of these tasks are just related to dealing with that markdown, either creating it or compiling a MAML document. Publish, we'll just publish this output module to the PowerShell gallery. Clean will ensure that the module is removed and maybe delete an output directory. And compile. This can get very advanced depending on what you want to, how you want to build your module, and you want to take all these private and public folders or files and stick them in one big PSM1. Maybe you have PowerShell classes, and I can talk offline about some of the gotchas with dealing with classes and modules and where they should go, how do you build them. So now let's actually see what that looks like. So I have this wrapper script called build, which all it does is really execute Psake. And I'm going to deal a task of build. That executed pretty quickly, but you can see it executing these various tasks for init, which is showing just some output variables, running my clean task, compile, etc., build ultimately. And build will say it output it to this out folder. Here. So here is the output, the quote-unquote built module. It also did markdown. So your question about like the MAML-based help, the comment-based help got converted to markdown, and then that markdown got converted to XML. This docs folder that wasn't there before got created. Now I have markdown documents for help. And that got converted into XML here and localized into English. But if you wanted to build this for other languages, you has support for that as well. And let me just run a different task here. I can say build help. This is basically a wrapper that runs the get ps script task function, and I can see all the available tasks for me to run, what the description is for them, and what they depend on. So I can run, let's just say, oh, I won't run the publish, but I'll just run the analyze. Analyze also just had to build, clean it, compile it, create the markdown, build it, then analyze. And then it would show me PowerShell Script Analyzer warnings, or in the way I wrote it, if I had PS Script Analyzer errors, I would actually fail that task. I would throw an error, and Psake would determine that that was a failing lint check. So that's Psake at a very, really quick overview of what it is. So that was a lot of code just to run all these tests. And if you're doing a lot of PowerShell modules, that's code that you duplicate in every single project, which most people do. I do as well, but I don't like doing that. And every time you copy in that code, you're going to tweak it a little bit here. You're going to forget that tweak over here. So you're going to start to drift in how you build these things. So what do we want to do is we want to share these tasks. Why do we want to do that? Well, like I said, we want to reduce all this boilerplate code and put this in one spot and just reference it and quit repeating ourselves. And standardize across all these projects. Ultimately, that will help us improve the quality of all these tasks because they're the same. If I improve it once, I improve it for everything. And because they're shared, I can actually publish these tasks as a module in the PowerShell Gallery, and other people can consume them, so no one has to reinvent the wheel. So that's why I created this other PowerShell project called PowerShellBuild. And essentially what this is just using a PowerShell module as a vehicle to deliver a Psake task to people. So PowerShell module has a manifest and a PSM1, and you publish it to the gallery. In this case, I'm using that to just bundle with it a couple helper functions and a Psake file that Psake will know how to read from a module. And this is your common task that you would want to do to build a module. So you want to clean, build, analyze, pester, test it, and publish it, and a couple helper functions as well. And if you can see that, that's the output of what it would look like. And then I'll show you it live. So let's look at the demo of that. Demo 2, this is basically the same module. I have included a whole bunch of other files here, and this is usually how I lay out my projects, but there's a lot of boilerplate scaffolding that you kind of do, especially with bigger open source projects. It's not just the PowerShell code, it's your README file, it's markdown files, it's contributors, it's code of conduct, it's your YAML file of choice for whatever CI tool you're using, tests, VS Code setting. I mean, it goes on and on of all those other ancillary files that you'd have to do every time you stand up a project. But PowerShellBuild specifically just deals with reducing the boilerplate for Psake itself. So you still have a Psake file, but in it, you're basically doing one command to tell it to go get all the tasks from this other module. So in this case, I added in the latest version of Psake, which is still unreleased. I'll release it. It's actually technically beta on the PowerShell Gallery, but you can download it and try it if you want to. But it will, you tell it, I want to run the test task, but it's not a local task. I want to go get it from the module PowerShellBuild, and I can optionally specify a version, and thanks to Build, that logic got better where you can specify a minimum, maximum, and a couple other options, I think, for how to do a version. So all of that other Psake code is now gone. What you can also do with PowerShellBuild is since you're using all these shared tasks and they can be opinionated, I may want to tweak how they run it for my environment. So PowerShellBuild also allows you to specify, kind of change the behavior of how they operate. So in this case, I don't want to compile the module into one big PSM1, but if I do, I can just set this to true, and that will actually, the task that it runs will change its behavior and actually compile it into a big PSM1. There is, oh, come on, get out of there. I am pressing escape, I swear. Okay. So here's the Git repo for PowerShellBuild. In here is a list of all the different properties that you can tweak and what they do. And this is how you can control the execution basically of every one of these tasks. By default, though, you don't have to change anything. It will just, if you're following the prevailing kind of convention of how to build a PowerShell module, it'll just work. So let's run this one. And I'll run the build task. Again, basically did the same thing, but none of that code lived in my project. It all got pulled from a PowerShell module that I installed on my system. So that's a nice way to a helper function to kind of standardize how your PowerShell projects are built, how they're tested, how they're deployed, is you can just pull all that code from a common code base. Oops. Again, you can run a help. You can see all the, even though none of that's listed here, Psake is realizing that you're wanting to pull this from a shared task. And it's as if all of those tasks were actually in line in this file. Okay. So that's PowerShellBuild. So there's still a ton of non-PowerShell in our PowerShell project. And it is for our own good, but we can make it easier. You still want all these files about code of conduct and README and your YAML file and all that. You still want that to build a high quality project. But again, you have the issue of every time I want to build a project, I'm copying and pasting from some other project and then tweaking, copying and pasting from another one, and then et cetera. You copy, I've done this. I've copied from a copy from a copy, and then all of a sudden these things are all just a little bit different. So I created this other project called Stucco, and this is an opinion. So let me get back up and say Plaster is another PowerShell project. It's on the PowerShell organization on GitHub, mostly maintained by Microsoft and some other community members. And it's a templating framework to build mostly for PowerShell projects. So you can take some templatized code, run it through Plaster, give it some variables, and it'll basically replace those variables with whatever values you want, and then you have an output module. You can do this, I think NPM does this. I think you can do this with a lot of different tools. You can kind of take a template, give it some parameters, and it'll output a built project for you. Plaster is kind of what that is for PowerShell. By itself, it has a very basic template for a PowerShell module. But this is, like I said, this is opinionated. This is how I like to build projects. I like to put in a choice of a license, your changelog, markdown file, a code of conduct, optionally read the docs, platyps, ps depend, appare. I mean, it goes on, and often, and I've joked before that a lot of times, most of the time, I would argue, all of this scaffolding is probably more code than your actual project itself. So we want to make it easier to build all that stuff, and that's what Stucco does. So let me give you an example of that. All right, so my demo3 folder has one file in it. Let me just show you that here. And what we're going to do is we're going to use Plaster to go, and Stucco is distributed as a PowerShell module, so you just install it from the gallery. You can run get Plaster template say include all installed modules. It will inspect every module in your PowerShell, in your environment, your PS module path, looking for ones that look like plaster templates, and then you can filter on the Stucco one. That'll give you an object, and then you can pass that object to invoke plaster to actually build, to run the templating engine. So if we'll just do that, and we'll give it a name of a module. Give it a description, give it a version, and it'll default to 010. It'll determine your name, I think, based on your Git config. It'll release it'll attempt to, so you can change the name. You can have an option of Apache or MIT or no license at all. We'll default to MIT. I would encourage you, if you're going to use this, to include a code of conduct. If you want to have other people collaborate with you on this project, it's nice to kind of know how the rules are and what you want to do. Code of conduct should have an email address. I'll just put something here. MKDoc support. One of the big reasons why you would want your help file in Markdown is that now you can publish that help documentation on things like Read the Docs. So Read the Docs is a free website you can use for open source projects to kind of host your help documentation. They will natively read Markdown files, so that's why you want to convert your comment-based help into Markdown. MKDocs is a tool that will create that HTML version of those Markdown files. But I won't add that in this case. You can optionally say, yes, I want to support PowerShell classes. I won't in this case. I do want PlattyPS support. And I have a choice of CI/CD tools. And basically what this does is it drops a formed YAML file in the root of your project for AppVeyor or for Azure pipelines. So it'll default to Azure pipelines. Let's just actually say AppVeyor. And it will spit out all the templating. It'll execute the templating engine and dump all that stuff out for you. You can see it added some kind of meta documents for GitHub if you want to put this on GitHub about contributing. GitHub understands how to read these files, so if you're creating a new issue for this project, it'll use this issue template automatically. That's kind of a helpful thing. If you want to if they're going to do a pull request, GitHub will read this pull request template, so everything you kind of help standardize your projects. It has some helpful VS Code tasks if you want, and then the actual project itself is kind of just stubbed out for you with some tests as well. So these are the kind of standard tests that I deploy on projects. And these aren't actually testing the code itself. This is actually testing the help documentation and kind of like the meta things. Like I have a valid manifest, and my manifest version matches the version that I've set in my changelog, things like that. So those tests run to kind of catch these silly mistakes that you can kind of make from time to time. And like I said, it added the changelog, your code of conduct, your license, your MIT license, etc. So, and your Psake file pre-built to use the PowerShellBuild module. So it's very, very sparse. But I can take this now and just run tests and test my code, such it is. Actually run some pre-built pester tests for you to test your manifest. And it's just a nice way if you're building PowerShell modules to get all that stuff out of the way and just get, making sure you've covered all your bases, but get down to actually coding your project. So that is Stucco. So GitHub Actions and Psake. GitHub Actions, if people don't know what this is they released this in beta. It's actually still in beta now. You can try to get on the wait list. It's a little slow to get approved, I hear. But GitHub Actions is GitHub's way to not just do CI/CD, but just run arbitrary actions in response to things that happen in GitHub. Mostly that's like someone commits code. That's usually how CI tools get executed. But it doesn't have to be just that. It could be someone opens a pull request or submits an issue. I want to run a task in response to that. In the case of GitHub Actions, those tasks actually get executed as Docker containers that you provide to them. And they take care of running all that, but they run these tasks inside containers, and that means you can ship all kinds of fancy things inside those containers to do whatever you need to do. So I was lucky enough to get on the beta of this last year, and I created a GitHub action to run Psake tasks. Most of the people who maintain some of these projects, I mean, there's one to run NPM tasks, there's one to run Terraform, there's one to run most of these common things. You can, of course, either if you get in the beta or once they make this public, you can actually create your own containers or your own tasks to run as well. But it's nice to have all these kind of pre-built. So like I just said, there is I released a Psake GitHub action that will consume your Psake file that's in your root of your project and actually run that as an action inside a container in GitHub. This is kind of the structure of what that looks like. Similar to what a Psake file looks like, I want to define what my workflow is, in which case this workflow, go away, sorry, gets executed in response to a push. So I push some code into GitHub, this workflow will execute and trigger. Specifically, you can have a number of actions get executed in response to that. I'm going to run the Psake test action. The Psake test action is going to use the code that's in this Git repository right here, which is basically a little bit of PowerShell and a Docker file. Internally, what GitHub will do is they'll clone that down. They'll create a Docker container with that code, basically mount your project into it and run that. And then you can optionally say what Psake task you want to run when this happens. So let me give you a real quick demo of that. So here I have a playground project where I have a Psake file with some basic stuff to do some initialization, really just faking it out and saying, yes, I am generating docs, yes, I am publishing, yes, I am building, but I'm not actually doing anything. I'm just outputting text. And I have inside a .github folder is where you define this action. This is the visualization of it, and you can kind of see that here. You can also look at it raw, and this is normally how you would edit it. Recently, they just actually added this ability to run these tasks on a schedule. But you can say, okay, in response to a push, I'm going to run the publish task. If I look down at the publish task, that is going to use the GitHub action, the Psake GitHub action, and have it execute Psake for me. So to trigger this, let me just make a change to something. Actually, let's make a change to that file itself. And take off the schedule. So I've committed that, and I should look now in my actions, and in a second or two, it will execute this action in response to that commit. And if you're familiar with CI tools, this is very similar to where you can run your publish task or your test task or build your module or go get dependencies. It's just the way these actions execute in GitHub is that they're in containers and gives you a lot more ability to bundle in a lot of helper code into those, or just use other tasks that people have built. And you can see my init ran, and I can look at the log for that. You can actually see it building the container right here. It executed Psake right here. So that's GitHub Actions. And I would encourage you, if you want to play with that, get on the beta. Hopefully you'll get in, or they will release it soon to the general public. So let's talk about some good practices. I mentioned this earlier, but you want to build projects and then test them, not test, then build. Oftentimes that will technically work, and especially with PowerShell, I can write some PowerShell and separate functions and separate scripts, run Pester on them or run Script Analyzer on them, but then I build it into a module and then I ship the module. Well, what I've done is I've actually just shipped up something that haven't tested. It's changed since I actually tested it. So make sure if you're doing this that you want to build, then test, not test, then build. You also want to test your help documentation. So I include some support in this in things like Stucco and PowerShellBuild. But you want to make sure that when you're shipping PowerShell code that you actually have help documentation for that. At least like I have help for each public function. Ideally, I have a comment about what each parameter does, and hopefully at least one example. So I want to make sure I at least get bare bones help documentation. So I want to run tests as I build things to validate that I do that. Those examples also should be actually tested with Pester. So you're just putting in an example. You can put a command in there, whatever command in there you want. To provide a good experience for your users, though, that command actually should be tested to make sure that you haven't introduced a break and change later and then you forgot to update the example. Testing is cheap. Do it often. Do it all the time. That's why you have all these things to test all your code as often as you need to. You can use a build tool, it's like Psake, like Rake, like Cake, like Invoke Build, like all of these other tools, or not. You can just run straight PowerShell, and a lot of people do this, and that's totally cool too. As long as you're doing these basic steps, that's the main thing. Because we want to remove all these manual steps. We want to get rid of them. So that's all I have for you. Thank you very much. Like you said, my name is Brandon Olin. I am a SRE at Stack Overflow. Microsoft MVP, the Dev Black Ops is where you pretty much find me on the internet. So, thank you very much.
Any questions in the room? We did have one question online.
Sure.
And the question was, when you're building the PSM1 file and you're using PowerShell classes, what's going to go in first in the file and overall as far as functions and classes, right? Mm-hmm. And can you also have some control over the order that classes are put in the file in case there are dependencies between the classes themselves?
Yes. So the way I do it, if I'm going to do classes, I put the classes in the PSM1 first before the functions. Oftentimes those functions will have, they're using the classes, so they have a dependency on those classes, and the way PowerShell parses that file, if those classes are, after the function, you're going to get an error. So those classes have to be defined first, unfortunately. And with ordering, if you have classes that depend on other classes, they need to be ordered in that dependency chain as well. So because of the way PowerShell parses that file, you can't have class A depends on B. You can't have class B or you basically can't have classes that depend on others out of order. There is various ways you can automate the building of a module that had a bunch of classes, and especially classes that have dependencies on each other. One method is pretty crude but effective, is basically name the files like 01, 02, 03 in the order that you want the dependencies, and then enumerate them in that order and concatenate them into the PSM1 in that order. Caveat is if you ever add a new class, inserting it into there, then you have that whole thing of go to 10, go to 20, and now we need to insert a go to 15 thing, so you got to reorder them. I believe there's another PowerShell project called Module Builder, which I think is planning to add, or if it doesn't already have support for how to build a module that knows how to deal with classes. But that is, I don't think that's a solved problem yet.
Cool. And so you're the maintainer for Psake now, and I'm wondering if there's a story behind how you became the maintainer for that? Like you knew the maintainer personally, and like how did that happen?
So I became the maintainer of Psake because at my previous job we were doing a whole bunch of stuff with Psake, and I based a lot of automation around it. And at the time, Microsoft was there was an open issue on the project about it needed a new maintainer, and then Microsoft. The PowerShell team planned on becoming the maintainer. I don't think they really wanted to do it, but someone had to. And then that ended up not happening, and I just kind of chimed in on the issue and saying, I'll do it, because I use it and I'm vested in it. And the person who was maintaining it also is the maintainer of Cake. If you know what that is, that's a very similar project, but it's all C# based. So if you're doing a lot of stuff with C#, I would actually encourage you also to look at Cake. But he's one of the maintainers of that. He was also maintaining Psake, and he was willing, say, here, you can totally do this.
And so how did you get the idea of distributing the tasks through modules? Was there like a light bulb moment for you about that?
Well, modules are the kind of really the only way to kind of version and distribute things in PowerShell. So you don't have to put actual code in that module. You can just use a module as a vehicle to publish things. So you need a manifest, and you need to add some other files in there. I'm using PowerShell modules. It's just a way to version and distribute something. So the way Psake is written with support for shared tasks is it will look for a PowerShell module. You give it the name of a module. It will actually go find where that module is installed locally, and expect a Psake file to be at the root of that module, and just loads it as if that module, or as if that Psake file was in your project. So it just uses modules as a way to ship code around and version it.
Awesome. Any other questions? Very cool. We'll go back to here.
Okay.
All right. Thanks, everyone. So this is the part of the meeting where we'll be shutting down the live stream shortly. Thanks for everybody who watched online. Thanks for everybody who will watch on YouTube in the future. Hello from the past. Here in person, when we shut down the live stream, if you choose to come in person at some point, you can participate with us, and we'll do some introductions, do some networking in the room, maybe talk about some PowerShell news if we want to talk about that, and then just hang out and talk about each other's day maybe. So thanks a lot to everybody watching online, and we'll see you next time. And everybody in here, just stand by.